Our objective is to solve quadratic equations with complex solutions by taking the square root. So remember, whenever you're dealing with quadratic equations, you know you're dealing with an x squared somewhere in there and no exponent larger than that. When you're dealing with complex solutions, you're dealing with square roots of negatives or i's. And we're just going to try to solve a quadratic equation that has solutions that involve imaginary numbers. Here's our first example. If I have negative 3x squared equals 81, step one, I got to work towards getting my x by itself. This is negative 3 times x squared. To undo that multiplication, I'm going to divide both sides by negative 3. These cancel out. This will be x squared equals, and now we got to work out 81 divided by negative 3. Well, positive divided by a negative is going to be negative, so I know that's going to be negative right there. 3 goes into 81. 3 goes into 8 twice. 3 times 8, or 2 times 3 is 6. Subtract. 8 minus 6 is 2. Bring down the 1. And 3 goes into 21 7 times. So now I have x squared equals negative 27. From here, I want to take the square root of both sides. And remember, anytime I square root both sides, I want to make sure that I include this plus or minus here. So x is going to be equal to plus or minus the square root of negative 27. From here, anytime I take the square root of a negative, I know that's just going to be an I out front. So this is plus or minus I root 27. Now I just need to break down this square root of 27. 27 is the same thing as 9 times 3. 9 is my largest perfect square number that evenly divides 27. And now I can break this up and I can say, well, this is root 9 times root 3. And the root of 9 is just 3. This square root of 3 can't be simplified, so that's just root 3. And my final answer is plus or minus 3i root 3, or if you like, you can put the I at the end. Just be careful, make sure it doesn't look like your I is underneath this radical. That's the same thing as plus or minus 3 root 3 times I.